Most people think of creatine as a muscle supplement, but could taking creatine actually help with things like memory, mental fatigue, or even how your brain performs when you're sleep deprived? I'm Dr. Elizabeth Miller, and today we're looking at the brain benefits of creatine and where the science is actually strong versus where it's still emerging. To understand why creatine might affect your brain, we need to go back to something we've talked about earlier in this series, ATP. ATP is essentially the usable energy currency of your cells. Your muscles need ATP to contract, but your neurons need ATP too. And your brain is incredibly energy hungry, so despite accounting for only about 2% of your body weight, your brain uses roughly 20% of the body's energy at rest. That energy is being used constantly to maintain electrical gradients across neurons, send signals, recycle neurotransmitters, and basically keep your brain functioning. This is where creatine comes in. Inside the brain, just like muscle cells, creatine can be converted into phosphocreatine. Phosphocreatine acts almost like a rechargeable backup battery. When ATP gets used and becomes ADP, phosphocreatine can donate a phosphate group to help regenerate ATP. So rather than thinking of creatine as something that stimulates your brain like caffeine does, think of it as something that helps your brain buffer its energy supply. And this is important to keep in mind when we look at the research, because some of the most interesting benefits seem to appear when the brain is being pushed into an energy deficit. If you're well rested, well nourished, and sitting on the couch doing a crossword puzzle, taking creatine probably isn't suddenly going to turn you into a cognitive superhero. But what happens when your brain is under metabolic stress? Researchers have looked at creatine during situations like prolonged cognitive tasks, sleep deprivation, aging, and other conditions where the brain's energy demands may be harder to meet. And there's evidence that creatine supplementation can actually increase creatine stores in the brain. This increase seems to be smaller and less predictable than the increase we see in muscles, partly because creatine has to cross the blood-brain barrier. But increasing that energy reserve could potentially help the brain maintain ATP availability when demand increases. And that might explain why some studies show improvements in mental fatigue and cognitive performance, particularly when the brain is under stress. So creatine may be less of a traditional brain booster and more of a brain energy buffer. What happens when you're sleep deprived? One of the coolest studies in this area was published in 2024. Researchers deliberately sleep deprived their participants and then gave them either creatine or a placebo. Sleep deprivation normally impairs cognitive performance and changes energy metabolism within the brain. But after creatine, researchers actually measured changes in brain energy metabolites, and participants performed better on cognitive testing and processing speed compared with the placebo. They also reported less fatigue. Now there's an important catch. This study used a very large single dose, so 0.35 grams per kilogram of body weight. For a 70 kilogram person, that's about 25 grams of creatine all at once. So I would absolutely not interpret this study as evidence that you should take 25 grams of creatine whenever you've had a bad night's sleep. It was a small experimental study designed to understand what creatine might be doing inside the brain. But it gives us a really interesting clue that when the brain is struggling to meet its energy demand, having more creatine available may help it maintain cognitive performance. And that could explain why benefits of creatine aren't necessarily identical in every person or in every situation. Does creatine improve memory? This is probably where we have some of the strongest evidence for cognition. Another 2024 systematic review and meta-analysis looked at 16 randomized controlled trials involving 492 adults. Overall, creatine supplementation was associated with improvements in memory. There were also positive findings for attention time and information processing speed. But there are some nuances here. Researchers did not find a significant improvement in overall cognitive function or executive function. And when they rated the quality of the evidence for memory was considered moderate certainty, where the evidence for the processing speed and several other cognitive outcomes was considered lower certainty. So again, I wouldn't say that taking creatine will make you become smarter. A better interpretation would be that creatine appears to have modest beneficial effects on certain aspects of cognition, particularly memory, with other cognitive benefits still being investigated. Do vegetarians and vegans benefit more? Creatine is naturally found primarily in animal foods, particularly meat and fish. So vegetarians and vegans aren't necessarily creatine deficient, but because they're getting little or no creatine from food, they tend to have lower creatine stores, particularly in the muscle. And some cognitive studies have suggested that vegetarians may experience larger improvements in certain cognitive measures after supplementation. The theory is pretty straightforward. If your baseline creatine availability is low, you may have more room to respond when you take the supplement. But the research isn't consistent enough yet to say that vegetarians or vegans will definitely experience greater benefits. It's better viewed as a population where creatine supplementation may be particularly interesting. What about creatine and depression? This is an area where we think we need to be especially careful with how we talk about the research. Creatine is being studied in depression because brain energy metabolism and mitochondrial function appear to be altered in at least some people with depression. That has led researchers to ask whether supporting the phosphocreatine energy system could potentially have an antidepressant effect or enhance the effects of conventional treatment. A 2025 systematic review looked at 11 trials involving more than 1,000 participants. At first glance, the results were promising. Creatine was associated with a small to moderate reduction in depression symptoms. But when the researchers looked more closely, the average improvement was actually below the threshold they considered clinically important. There was also a substantial variation between studies, and there was a little bit of potential bias. So overall, the researchers rated the certainty of the evidence as low. So this is definitely not evidence that creatine should replace antidepressants, psychotherapy, or other established treatments for depression. It's another emerging area of research that may eventually tell us more about the relationship between cellular energy metabolism and mental health. How about creatine and concussions? Another emerging area is traumatic brain injury, including concussions. So after a brain injury, neurons can experience a massive metabolic change. Energy demand increases at exactly the same time that the brain's ability to generate that energy can become impaired. That has made creatine an interesting potential neuroprotective compound. There are some preliminary human studies, including research in children and adolescents, along with animal research suggesting that there is potential benefit. But the clinical evidence is still very limited, so we don't currently have enough high-quality human trials to say that taking creatine prevents a concussion or that it should be used as a standard concussion treatment. So again, this belongs in the category of promising research. How much creatine do you need for brain benefits? So if you're taking creatine specifically for brain health, is 3 to 5 grams per day enough? Maybe, but there is growing research suggesting that the dose needed to meaningfully increase creatine in the brain may be higher than the dose we typically use for muscle. Skeletal muscle is very responsive to creatine supplementation, which is why 3 to 5 grams per day works so reliably for maintaining muscle creatine stores. But the brain is different. So creatine, again, has to cross that blood-brain barrier. In the brain, creatine levels appear to increase more slowly and to a smaller degree than they do in the muscle. Because of this, researchers studying cognitive and neuro effects have often used higher doses, longer supplementation periods, or both. And there is emerging evidence suggesting that doses around 10 grams per day may be more appropriate when the goal is specifically the brain health. So some studies have gone even higher, particularly when researchers are looking at situations where the brain is under significant metabolic stress, like sleep deprivation. But I, again, would not interpret that as taking 25 grams of creatine a day. Right now, I think the most reasonable way to look at the research is 3 to 5 grams a day for muscle stores. And if your primary goal is brain health, somewhere closer to 10 grams a day may be worth considering. And if you're taking those higher doses, splitting it into 2 smaller doses, for example 5 grams twice a day, may also help reduce digestive side effects. So does creatine help your brain? Potentially, and this is one of the most exciting areas of creatine research right now. We have fairly encouraging evidence for memory and interesting findings for mental fatigue and processing speed, especially when the brain is under metabolic stress like sleep deprivation. We're also seeing creatine investigated in areas like depression and traumatic brain injury, but those applications are still early in the research, so we shouldn't be treating them as established therapies. And I think the biggest takeaway is that creatine isn't really just a muscle supplement, it's an energy supplement. Muscles just happen to store most of it, which is why that's where we've focused all our attention. But if your brain relies on the same creatine systems to help regenerate ATP, we're only beginning to understand what supporting that system might mean for our brain health. If you found this video interesting, stay tuned for the next one where we're getting into one of my favorite areas of creatine research, women's health. We'll look at why creatine may become even more relevant as women age and what the research shows for muscle, bone, brain health, and menopause. Subscribe so you don't miss out.